Yeah. Okay, I'm not a singer, so I'm not sure I would be good with this thing. Um, yeah, so the Wicks formation. Why are we interested in the Wicks formation, and why we study this fauna? The first answer to this is the fact that we could. Nobody really were really interested in working on the Wicks formation. Maybe I can try without it. Can you hear me loud and clear? Not enough? Come on. Okay, so I'm stuck with it. So yeah, we started to work on Wicks formation because this was one of the conserved Lagerstätte that was available, to be honest. But also because it contributes to fill some temporal gaps in the fossil record of soft body organisms. Like 15 years ago or 20 years ago, there were a pretty good fossil record for this kind of organism in the Cambrian series 2 and 3, in the upper Ordovician too. Over the last 15 years, many new localities have been found, or some strata have been acknowledged as conserved Lagerstätten. And the most important of this one is probably the Fesuata here. Most important because it's just in the middle of this huge temporal gap between the upper Ordovician and the Cambrian series 3. But also because of the diversity of the fauna, of the abundance of the fossils. One of the lessons of the study of this Fesuata shale and the Fesuata biota is that there are some organisms that we thought to evolve much later in the Ordovician, if not in the Silurian, that are already present in the early Ordovician and with a very, very modern morphology, which means that they probably evolved in the late Cambrian, and then the greater interest for this time period, which is still kind of not really barren of any conserved Lagerstätten, but it's pretty sporadical. Of course, there is one very important. Oh yeah, I need to precise this. The late Cambrian in United States, at least according to some author, is start a bit earlier than the Thuringians. That's why it would be a bit important with the Wicks formation. That's why it's represented like this here. Sorry. Okay. Yeah, so as I said, this time period is still almost barren in terms of exceptional preservation. There is this very important conserved Lagerstätte that we call the alum shale, or that has yielded the ocean fauna. But as always with this kind of preservation, what we call the ocean type preservation, which is basically a phosphatization of the remains, we only preserve tiny organisms or fragments of the organism. So it's very difficult. So it's very important for the evolution of crustaceans, but it's very difficult to compare this fauna to typical Burgess shale type faunas. There are new, there have been some recent and interesting discoveries, and one of these discoveries is in Canada, what we call the Mackay group, at least the Thuringian part of the Mackay group. There are some occurrences of exceptional preservation there. There is a poster just outside. In China too, with Guole. This is a locality that is promising, even if for now the material is still pretty limited, at least in terms of soft-bodied organism. But we think that if there is a more intense collecting effort in the future, it might prove to be very, very interesting. So we are stuck with the Wicks formation, which is not like a major improvement in the filling of this gap, because it's just slightly younger than the margin, which is just there. But it was considered as at least the upper two-thirds of the Wicks formation, where we find the exceptional preserved material. It was considered as late Cambrian, what we call the Cedaria trilobite zone, the beginning of the late Cambrian in Laurentia. Anyway, what I will try to show today is that even if it's not that different in terms of age compared to the margin, actually we start to witness a change, a kind of restricting of the animal communities at that time, or at least the premises of this restricting. So this is one of these conserved Lagerstätten that are present in the Great Basin region of the United States. It outcrops so there are 8 of them in the Great Basin, and 3 of them are in western central Utah, in what we call the Central House Range. This is the Florence Ranch, where we can find the wheeler, the margin, and the Weeks Formation. This is just a view of the area with the notch peak here, which is here. The Weeks Formation is way more restricted than the wheeler and the margin in term, especially. And if we want to study this fauna and this deposit, we need to go to the North Canyon, which is just here, where there are some abandoned quarries. This is what you can see here. Okay, so, and this is what one of these quarries looks like. So it's a bit messy with slabs everywhere, but it's not too difficult to dig there. So it's kind of convenient. About the geological setting, I will be very fast on this part. Maybe you know that in the Cambrian, especially starting in the mid-early Cambrian, but in the middle Cambrian it's very well expressed. There is the Ranchia is rimmed by a carbonate platform, which kind of separates some proximal environment from distal shelf environment and upper slope environment. And that's why we recognize in general three fascious belt, what we call the inner detrital belt, the middle carbonate platform, and the outer detrital belt. So in this part of Utah, we should have only this kind of carbonate sediment here. And actually, very locally, there has been the development of a basin where there was a deposition of, or I should say, yeah, more typical sediment, more typical of deeper water environment, what we call the outer detrital belt. And so it developed in the late stage 5 and started to be filled with the wheeler formation, then the margin formation, then the Weeks Formation, and we are back to the carbonate settings with the Yaw Formation. So in the upper part of the Weeks Formation, there is clearly a very important shadowing of the environment. And this is what we thought that could explain why the fauna was a bit different. We thought initially that maybe the environment was a bit different, a bit shallower water. But actually the work of my colleague Bob Gaines showed that it is a quite depositional environment on a distal carbonate ramp below stone wave base, basically the same kind of settings and the margin and the wheeler, and many Cambrian Lagerstätten. So it's interesting. It's a bit different from what we thought, but it's interesting because it means that we can study an animal community locally, living in a particular environment through time, because this sequence is continuous, and in each of these units there are some strata where you can find exceptionally preserved fossils. So we've been there twice. In 2015 we collected massively, and now we've got a much better idea of what is the composition of the fauna. This is what I will just talk about the major characteristic of the fauna and how it compares to the older faunas. So we have a pretty diverse fauna, 80 species roughly, belonging to 9 phyla. The fauna is dominated by arthropods, and sponges and brachiopods. In terms of abundance, it's mostly brachiopods, they are just everywhere, and trilobites and then non-trilobite arthropods. So basically when you see like this, something like arthropods, sponges, brachiopods, it's like very typical of what you can find in early and middle Cambrian exceptionally preserved fauna, or in general what we call the Cambrian evolutionary fauna. This is also very well illustrated here with a comparison with the margin and the wheeler. It's just the contribution of each of these phylum, to the species diversity, and you can see that we have very, very similar distribution here between the margin, the weeks, and the wheeler. There's just a bit more arthropods here, but it's just because we are, in our group, we are mostly arthropod specialists, so it's obviously a bias. Just to say that at the phylum, the level, the taxonomic structure of this fauna is very similar to what we observe in early and middle Cambrian Burgess Shale type faunas. It's also the case when we take a look at the different components. Some of the components are very typical of early and middle Cambrian Burgess Shale type faunas. This is the case of the sponges. From what I can tell, most of them are already present in the Burgess Shale, if not earlier. The cnidaries are forms we know from the Burgess Shale, from the margin, the wheeler, so older deposits. The case also of what we call the priapulids worms. I included there the Palaeontological, which is actually a bit different, but these forms, for instance, is very typical for a Palaeontological of the Cambrian with very simple disc-shaped plates. It's not the kind of stuff you can find in the Fizzwater, for instance. Hyolithids, typical of early and middle Cambrian, clearly. And just to mention it, because we've got this specimen which really looks like this forms here. It's only known from one specimen here. It's from the Kinzers Formation, and it's early Cambrian in age, and we think that it's the same thing. So again, some kind of a kind of early middle Cambrian signature for this fauna. It's also true with the arthropods, with probably the youngest representative of this genus, Anomeracaris, which is well known in, of course, in the Burgess Shale, but in many other places like Shenyang. Bradorids too, with the form. Actually, these two species have been interpreted as the first planktonic bradorids, which is kind of interesting because we find them both together in the Weeks Formation, while they are in different geographic areas. They were known from different geographic areas. Yes, another example of an arthropod more typical of early and middle Cambrian Burgess Shale type deposit. But if we take a look at the trilobites, we are clearly in the late Cambrian. Okay, it's kind of biased because the trilobite are used for the biostratigraphy, but it's really massive. The trilobite fauna is pretty diverse with 20 species, and all but one are found in the two upper thirds of the Weeks Formation, which means the late Cambrian part of it. Only this form is in the lowest part. And for most of these genera, it's the first occurrence in the fossil record. So they are known from strata roughly similar in age or younger. So already we have a sense that there is a change in the composition of the fauna with a clear late Cambrian signature. It is confirmed with some arthropods that we call the aglaspidid, that are mostly known from the Thuringian, mostly of United States, but also elsewhere in the world. They are not always very well preserved, but at least 4 taxa are present. And what is interesting is that we've got some appendages preserved sometimes. There is this form too, which is pretty close to aglaspidid, and is very common in the Weeks Formation. We described this other group of aglaspidid, what we call the Ordovician type aglaspidid, with this form Tremaglaspis, which was as yet known from the Tremadocean of Wales and Morocco, but it's already present in the Gusengian, late Gusengian of the Weeks Formation. Saluton Echinoderms also, it's one of the oldest representative of this group, which is more diverse in the Thuringian and then in the Ordovicians, never a very big one, but it's one of the oldest form. The oldest form is from the Durmian. There is this form, this mollusk, it's another, just to illustrate from the different groups that we've got some kind of modern forms. Tergomian are present in the early Cambrian, but what is interesting with this one is that it's a very large shell, and it seems, from what I've read, that there is a very important increase in size in the late Cambrian for the shell size. Just to say that there are some newcomers, and among them, some of them are really problematic. I'm almost done. This is the case with a couple of arthropods here. This Falcatemmacaris with a very strange posterior part of the body. You see this part of the body is very unusual even for an aglaspidid, for instance. This form, which looks like a bit like Sania from the Burgess Shale for the expert of arthropods, but when I studied it, especially the details of it, I was convinced that it was very different. And what you see here are the digestive glands. But it's not only in the arthropods that we can see that. We have also some weirdos in other groups, and if you can help me, it would be really, really useful, especially with this form, which is obviously not an arthropod. It is pretty big. It's like 6 or 7 centimeters in length, with a kind of sheath here. You can see it here, and with a very special ornamentation or sculpture here. And everything is phosphatized, but this part was obviously a kind of peduncle or some sort, but it's like massively phosphatized. So if you can help me, just talk to me outside. Just to say that the Weeks Formation is, by many aspects, a typical Burgess Shale type fauna, Cambrian Burgess Shale type fauna. But there are newcomers that are with a greater success in the Thuringian, if not in the Ordovician, but also with newcomers that are only known from the Weeks Formation. And what I think is that the late Cambrian is probably not the most interesting period when you study the diversity, because it's supposed to be a period of plateau in terms of diversity. But there is something very interesting in terms of the restructuring of the communities. So hopefully we will find more information in the forensic. Thank you.